Hello, back to Energy 101. We're talking about electric power technologies, and today we're going to talk about fossil fuel technologies, which of course primarily comprised of the coal and natural gas, but we're also throwing in hydro, since it doesn't really fit topic-wise, but it's a good place to put it compared to other options. So fossil fuel electric power technologies plus hydro, I should add. Coal power plants, which are the most dominant. And here's a picture of one. And let me just comment that this all looks like, with all those plumes coming out of the stacks, it looks like that there's a lot of pollution. Most, in fact, over 90% of these plumes is just water vapor. As a matter of fact, the plumes right here, that is all water vapor, because those are cooling towers, and warm water that the coal power plant has rejected heat to is heated up and is put in and sprayed into these cooling towers, and air is blown in the opposite direction and evaporates the water, and the evaporation of some of the water cools the remainder of the water. So all of these plumes right here are basically water vapor. Now this is a plume from the combustion process, those tall stacks right there. And those do have some pollution. They got a lot of cleanup down here to clean up the ash, the soot to keep the particulate matter out. They clean up sulfur dioxide, and nitric oxides get cleaned up there also. So that's what the overall plant looks like. I can't tell much about what goes on inside, but here's a quick diagram of what goes on inside the power plant. You have a coal storage, that the coal is put into a conveyor and is brought to the combustion chamber. That's a boiler or a furnace. It's burned, and water is pumped into the pipes, the tubes, boiler tubes we call them, inside the boiler, and the water is boiled to high pressure steam. And the steam is then carried over to a steam turbine. These are turbine wheels that, when the steam expands from a high pressure to a lower pressure, which they do is they flow in, this is shown as a two-way turbine here, and comes down, it spins the shaft, and the shaft turns an electric generator, and the electric generator, of course, is the wires carried out to a transformer substation and to adjust the voltage, and then it's distributed over transmission lines or distribution lines. So that's the basic components of the power plant. And of course, as we mentioned, we have to throw away about 2/3 of the energy that is released in the combustion process because of the second law of thermodynamics, or the quality of energy in converting heat to electricity, the heat generated by the combustion. So this steam, in order to complete the cycle, has to be cooled back down and condensed, and that's done with a condenser. And river water, power plants are built on rivers, is brought in and it's warmed up as they pick up the heat from the steam and is carried back to the river. That's one situation, but in the case of the picture where I just showed you, these are cooling towers. So in that case, the water is carried to a cooling tower, and approximately 2 or 3 or 4% of it is evaporated, and that cools it and is brought back. So it uses water and by putting it in, evaporating and putting it in the atmosphere, whereas this closed system takes the water and warm water and just puts it back to the river. And of course, that's the thermal pollution issue that has restrictions on it regarding how much thermal energy and how hot the water can be returning it to the river. So that's the coal-fired power plant. A gas turbine is a different situation. There's no steam involved in just a simple gas turbine, although we combine it with a steam cycle that does involve steam. But this is a picture of the hardware of a 400 megawatt gas turbine. These gas turbines are derivatives of aircraft jet engines, and the technology of developing the high temperature blades that take the high temperature gases and spinning it at high speed was developed by the Department of Defense for the military and jet aircraft. So this is a fundamental basic technology that was developed by the military for fighter aircraft and other aircraft to make jet engines more efficient, and that technology has been brought down to gas turbine power plants. And in the combined cycle, what we call combined cycle, the hot exhaust gases that are coming out of the engine, these are hot gases. You put it through a boiler, so these gases are put through the boiler that you see back here, right here. So rather than putting coal and burning coal to create hot gases to boil the water, you do it with the hot gases coming out of the gas turbine. That's called a combined cycle because you're combining a steam cycle with a gas turbine cycle. So there's two kinds of gas turbine power plants. One is a simple gas turbine that just has the gas turbine by itself, and the shaft turns a generator to generate electricity, and then the hot gases are just exhausted. And the combined cycle then, whereas I just mentioned, the hot gases go through and boil water to steam and drive a steam power plant. So you have two generators, one generator being turned by the gas turbine, the other generator being turned by the steam turbine in the steam power cycle. Hydro, I mentioned, of course, this is not fossil, but threw it in here, is where you have a dam, and the dam, it builds up water behind it and creates a lake. And most of these dams that we are currently operating to get hydroelectricity from were created with the primary motivation of recreation of the lakes. People like water. They build houses around the lakes and boat on the lakes, and etc. So, but this water that is at high pressure behind the dam, at the bottom of the dam, can be used to generate electricity, as we see in the next slide with this diagram. So here you have the reservoir, the lake back here, and you have the water pressure increases toward the bottom of the lake. So you have the high pressure water then come to a grate so that fish and things can't get in it and trash. And it comes through a pipe or penstock, and it goes through a water turbine. So we've seen three kinds of turbines so far. We've seen a steam turbine that's rotated with high pressure steam and high temperature steam. We had a gas turbine that is rotated with high temperature gases. That's gases that is just the air combusting natural gas and the exhaust products from that natural gas combustion process with mostly air. And then we have the water turbine. So it turns a generator and generates electricity like the other turbines do, and then it goes down into a river. This is a good way you can peak shave, so to speak, and save the water in the reservoir back here in the lake for the times when they need a high they have to meet a high power demand, like in the air conditioning season in the late afternoon, and then they release the water and generate a lot of electricity to generate power during the high power demand periods, which is the best way to utilize that water reserve, because there's not enough water in the lake to generate all the time, 365 days a year, 24 hours a day. So those are the three power technologies, electric power technologies with the general operating characteristics. The coal plant, the natural gas plant, and the hydro plant. One of them, of course, hydro is renewable. Thank you.